YouTube live started. You can shift to Word doc. Share screen, shift to Word doc.
Okay. Share screen. ఇప్పుడు వర్డ్ వస్తుందా మీకు వచ్చింది
ఇంకా బ్లాంక్ ఉంది స్క్రీన్ ఇందులో మన జూమ్ లో అయితే ఇంకేం రాలా
షేర్ స్క్రీన్ చెట్టానే బ్లాక్ ఉంది కదా
యా ఇట్స్ ఓపెన్
ఓపెన్
ఓపెన్ యూ చేంజ్ దట్ వ్యూ టు వ్యూ ఫుల్ స్క్రీన్ వ్యూ You are live. I'm logging off Zoom. You can go ahead with this only. No need for full screen. Start off.
Okay, done. ఇప్పుడు okay, so how do we get to see the questions from students?
So they'll be visible on the chat room. You have to open a YouTube. This thing I'll share with you the YouTube link, video link.
Yeah.
You can start off with the formulae and others. Discussion.
Yeah. So shall I start?
Yeah, please go ahead. I've been giving you the YouTube link. You open that on a different mobile or something.
Yeah. So shall I start? Yeah, please go ahead.
Yeah, I've seen that link. Yeah. So I could see students posting some messages here. Yeah, sure. Right. So can I start? Yeah. So good evening, students. Hope all of you are doing well, staying at your home and staying safe. So today's session is about fundamentals of good evening, students. Hope all of you are doing well. Yeah. So today's session is all about doing some basic overview of permutations and combinations and probability. So the idea is to teach you some fundamentals about these two topics. So let's get started with the basic idea of what is a permutation and what is a combination and what are the basic things that we learn from these two topics. And then we can go ahead and learn even probability. So we also have time for you to ask some queries so that I can address some of these questions. So let's get started through the concept of what we call as a permutation. So, right. Yeah. So basically, most of you would have studied the concept of permutation in association with what is called as a combination. So basically permutation is nothing but arrangement of things in a particular order. So the word order plays a very critical role. So why would I say the word order? Is like when you're going to watch a movie, let us say you book 3 tickets. Let's say there are 3 friends ABC who go to a movie and they basically book 3 tickets in a particular row. The order in which they sit makes a lot of difference to the viewing experience. For example, we have 3 friends, let's say ABC. So you can arrange them in this order. You can write A, B, C, starting with A, followed by B, and followed by C. And then you can put A in the same position, and you can interchange the positions of C and B. So where B is in the middle in the first position, and the C is in the middle in the second arrangement I have done. And similarly, you can start with B and you can interchange the positions of A and C. Same way you can do with B, and similarly you can also do the same arrangement with C, right? So you can see that in all 6 arrangements that I have done, you can see the same 3 people are sitting, right? But the order in which they sit is making a lot of difference. So when I use the word permutation, the most important thing that you guys need to remember is the order. The order of arrangement makes a lot of difference. For example, a number 24 and a number 42, both are created using the same 2 numbers, 2 and 4, but being in the units place and tens place, there is a lot of difference, guys. Okay, so please remember the order is very critical whenever we are doing the concept of permutations, right? So how do we represent the concept of permutation? Generally, you have a notation NPR. So what does the word P represent? P represents permutation. N represents the number of objects that you have at your disposal. R represents the number of things that you are choosing. For example, I have 5 people. Let's say I have 5 people and I have 3 seats, right, in which I have to make them sit. So obviously I have only 3 seats, so definitely I can choose only 3 people out of 5 people. Number of ways you can do it is 5p3. Now the question is, if there are 3 people, you can just do the counting manually. So if there are multiple, let's say if a larger sample is there, and if I have to choose a smaller sample out of a larger sample, then necessarily you should know the formula. So NPR, the formula basically tells you it is n factorial by n minus r factorial. N minus r in whole brackets factorial. Now the question is, what is factorial? I think all of you know. I'm presuming that factorial is nothing but multiplication of number with its preceding number till you get 1. For example, I'm doing 3 factorial, it is 3 into 2 into 1. I'm doing 4 factorial, 4 into 3 into 2 into 1, and so on. N factorial means n into n minus 1 into n minus 2, and so on. So when I have n minus r factorial, it is n minus r minus 1, and so on. So let's test it with 5p3, guys. Okay. So when I have 5p3, so how do we do it? So when I have 5p3, when I apply the formula of NPR, n factorial, that is 5 factorial by 5 minus 3 factorial. So all of you know 5 minus 3 is 2. So ultimately we'll end up having this computation as 5 factorial by 2 factorial. So this is something that we can simplify on our own, right? We can just do a normal multiplication and cancellation, and we'll end up getting the value as 60, right? 5 factorial is 120, 2 factorial is 2 into 1, 2, 120 by 2 is 60. So here you can see, most importantly, permutation is nothing but the concept of arrangement, and here the order is extremely critical, guys. Okay, so that is how we look at permutation. So how do we use permutation? Let me use a small example. So how many 3-digit numbers can you form using the digits 1, 2, 3, 4? Let us say I have 4 numbers, 1, 2, 3, 4 at my disposal. I have to form 3-digit numbers without repetition. So let us also be clear that there will be many cases where we are dealing with numbers with repetition and without repetition. So let's focus now on without repetition. So I can't use any number more than once. So I have to form a 3-digit number. So you can see 3 digits, units place, tens place, hundreds place. So you have to form a 3-digit number using 4 digits, 1, 2, 3, 4. How many ways can you do it? So the question is, since you do not have any zero, you can place the numbers at any position as you like. If there was a zero, then there was a worry that I don't want to place it in the leftmost position, because if I put zero, then rather it being a 3-digit number, it will become a 2-digit number. So 1, 2, 3, 4 is my options available, and you have to arrange them in 3 places. So direct way, using the formula, I can say the answer is 4p3. So when you use the word 4p3, you know how to apply the formula: n factorial by n minus 1 factorial, that is 4 factorial by 4 minus 1, 4 factorial by 4 minus 3, 1 factorial. So you know the number of ways in which you can do it, right? Which will be 24. Now the question is, how do we do it without the formula? Also we can do it. Now tell me, if you want to put a number in the units place, how many ways can you do it? You can use the number 1, you can use the number 2, you can use the number 3, and even you can use the number 4. So you can use any 4 numbers that you have. Please remember, this 4 is not a number. This is the number of options that you have at your disposal, right? So the units place can be filled by any 4 numbers that you have. Let us assume we have used 1 number, guys. Okay. Now, how many ways can I fill the tens place? Now that you have already used a number, you are left with only 3 other numbers. You can use any 3 out of the following. The number of ways you can fill the tens position is 3 ways, right? So let's assume I have used 1 more number. Now you are left with only 1 place to fill, and you have 2 options. So number of ways you can do it is 2 ways. So number of ways you can do it is 2 into 3 into 4, which will give you an answer of 24, right? So this is how you use the concept of permutation. Now the same thing, you can even start doing the same thing by counting it, but that would not serve any purpose. Reason being, guys, you know that it will take a lot of time. So this is how we go ahead with the concept of permutation. Now, where can we use permutation? Permutation is mostly used in the concept of arrangements, right? Please remember, permutation, yes, permutation is used in the concept of arrangement, right? And it is also used in the when you are preparing numbers, okay, right? So please keep that in perspective when we are trying to use permutations, okay, right? Okay, so let's move on to the next concept, right? Or shall we do one more example? Yeah, so let's do one more example, guys. So let's discuss the concept of permutation in the form of arrangement. Okay, so arrangement. So now whatever we have discussed with respect to numbers, this is called linear arrangement. So when I use the word linear arrangement, we are arranging the numbers in a straight line, like whatever we have discussed in a movie theater. So movie theater basically is make people sit in one row after the other. So for example, if I have to use the concept of permutation or arrangement, if I have to make people sit on a circle. So let me draw a circle for you guys. Okay. So let's assume I have to make these people A, B, C sit on a circular table having 3 chairs. Okay, right. Now the question is, how do you achieve that? And will the formula of NPR, which is n factorial by n minus r factorial, continue to hold good here? That is a question that you might have. So let me just answer it, guys. So please remember, circular permutations and linear permutations are completely different. So we may have to slightly modify our formula, guys. Okay, so let's learn how to do it. So let me just write down few things here. So A, B, C. Let's say one circle. Okay. A, C, B. Another circle. Right. So these are the 2 things that I have written. Keeping A as the first one, B, C, and C, B, I have interchanged their positions. Now you can see, if I am using a linear permutation or permutation in a straight line, guys, you would have observed that I would have used ABC, ACB, BCA, BAC, CAB, and CBA separately. Now the difference in a circular permutation is, if you start reading from A in my first diagram in the clockwise direction, you will get A, B, C. I'm just writing the arrangements below the circle. You start reading it from B, you will get B, C, A, if you have observed. If you start reading it from C, you will get C, A, B, because in a circle, there is no start, there is no end. everything is same. So one arrangement on a circle has counted for 3 arrangements, the same thing that we did on a straight line. Now you start with A here, here you'll get A, C, B. If you start with C, you'll get C, B, A. You start with B, you'll get B, A, C, right? So you can see that 3 arrangements and 3 arrangements which were counted individually in the previous case now are counted as same. So the 6 arrangements which we have counted on a linear line now has become only 2 arrangements on a circular table. So that's basically the difference. So what is the adjustment that we have to make, or how do you link those with this? For example, if I'm arranging n people in a straight line, the number of arrangements are n factorial. So for example, if I have to arrange 3 people in a straight line, we know it is 3 factorial. That is what we got. 3 into 2 into 1, that is 6, right? Now, if I have to arrange the same 3 people on a circle, since every arrangement is counted thrice, this is counted thrice, this is counted thrice. So everything is counted 3 times. We have to divide it by that factor to eliminate multiple countings. If I'm arranging 3 people, linear arrangement will be 3 factorial. By multiple countings is every counting is made thrice. If so, 3 factorial by 3, as you can see, you will get the answer as 2. So these are the 2 arrangements. So if I am doing it on a circular table, n factorial by n. So what does n factorial by n translate into? I think all of you know. N factorial by n translates into n minus 1 factorial. So guys, please remember, whenever we are doing circular arrangement, n factorial becomes n minus 1 whole factorial. So please remember this as your context. So this is the concept of permutation. So 2 things that I'm trying to tell you is permutations in a linear arrangement, permutations in a circular arrangement. Okay. So if I'm trying to arrange 3 people on a linear table, it will be 3 factorial. Same thing if I'm trying to do on a circular table, it will become 3 minus 1 whole factorial, that is 2 factorial, which is only 2. So this is basically the concept of permutation, guys. Okay. So where the order is extremely critical. Okay. Now guys, let's look at the concept of combination. Okay, right? So how are combinations used in our day-to-day life? Since you guys have already understood permutation, right? I think you will have no difficulty in understanding combination. Only thing we have to understand is where to use this, in which problem to use which concept. So that is one thing that I always had it out even as a student. So let's try to address those also today, guys. Okay. So let's move on to the second concept for today, which is called combination. Okay. Now, similar to permutations, combinations are also done using objects or people, but only difference here is there is no importance of the order, right? For example, if I have to select 3 people, if I have to select 3 people in my team, let us say I'm trying to form a team to execute a project, right? And I require 3 people. Let us say I have shortlisted 3 people, A, B, C. And remember, my requirement is 3 people. I have shortlisted 3 people. Now you may wonder, how is it different from a permutation? So you see, in a permutation, the order in which you take, or the order in which you arrange them, basically matters a lot. So ABC is different from ACB, BCA is different from BAC, CAB is different from CBA. But in a combination where I am trying to select these 3 people, the order in which I select them doesn't matter, because ultimately all 3 are part of the team. So whether it is ABC or ACB, whether it is BCA or BAC, or whether it is CAB or CBA, doesn't matter to me. So in a combination, order is not important. So all the 6 permutations that we have seen for ABC will become a single answer for a combination. So how do we define a combination? It is represented in the symbol NCR. So how is it different from an NPR? If you see in NPR, we have written NPR is n factorial by n minus r factorial. This is where we ended the formula for permutation. Now in combination, how is it different? You have the same formula, but you have an extra denominator called into r factorial. Why? Because wherever there is a multiple counting, you have to remove, right? So if you see permutations of three people or arranging three people in a line, basically you will get, I use the word permutation, you will get 3 factorial, which is 6. I have shown you how do we get 6, right? Now if I have to use the same answer for a combination, if I have to select a pool of 3 people and my requirement is 3, basically it is only the answer is 1, correct? So basically for permutation it is 3p3, for combination it is 3c3, or npr, selecting r objects from a sample of n where order is important. For a combination it is ncr where the order is not important. Okay, so let's try to basically discuss this in a small table and a small question, guys. Okay, so I'll draw a small table and help you understand this. Okay. Okay, so let us say boys and girls. Okay, right, let's look at the numbers. Let's say for a job interview we had 5 boys and 4 girls who have turned up for a job interview. The total number of positions that I have to fill are 3. So I have only 3 positions with me, and the total number of people who turned up for the job interview, number of boys are 5, number of girls are 4. So someone asked me, sir, in how many ways can you select them if there are no conditions attached to it, right? So if I have 5 boys and 4 girls, if I am not very concerned about their gender, so totally I have 9 people and I have to select 3 out of 9. So without any hesitation, I will write the answer as 9C3, because there is no restriction on whom I can choose. So you can choose all 3 boys, you can choose all 3 girls, you can choose a combination of boy and a girl, any combination that you may think of, provided the total does not exceed 3. So the answer is 9C3. Agreed. Now if I have to select all 3 boys only, then girls being part of your pool doesn't necessarily matter. So the answer now will become 5C3. Excuse me. Now if I have to select only girls, all 3, then one way I can do it is 4C3. So you might ask me, what if I want to use a combination of a boy and a girl? Let us say I want to select 2 boys and 1 girl. So since from a pool of 5, you are selecting 2, so I will write 5C2. And since the problem is not complete, the problem is complete only if you select all 3 people. Now you have selected only 2. You have to select 1 more girl into 4C1. This is called multiplication rule. Multiplication rule says that if you can do a task in n ways and another task in m ways, if you want to do them simultaneously, number of ways you can do it is n into m, or 5C2 into 4C1. That simplification you can do. So this way you can use combinations basically to select people and form committees. Okay, so that's basically the difference between permutation and combination. Hope everyone is clear with this. So we can also do some problems on combinations. Basically problems on combinations are always done where we have some restrictions with respect to people. So you as you can see, NCR formula is n factorial by n minus r factorial into r factorial. Okay, now now since we have discussed both concepts, right? So let me just show you the applications of these problems. Right, I'm just rubbing the concepts here. I'll just read out a problem for you guys. Let me start asking you one question on how will you approach this in the first place, right? So let us say you want to do this problem. Okay, so let's use one very popular cricketer to go about this problem. Okay, so let us assume we have Kohli. Okay, right? So let's use the word Kohli to solve our problem, guys. Okay, right? So I have Kohli, right, guys? I'm just underlining this. You can see Kohli is a 5-letter word where every letter is unique. Let us say I want you to identify the number of different words, that you can form using the letters of the word Kohli. I repeat, the number of different words that you can form using the letters of the word Koli. So Koli has 5 unique alphabets. Now the number of 5-letter words, if I use the word 2-letter words, that means you have to pick only 2. Now I am saying 5. So basically you have to form 5-letter words, 1, 2, 3, 4, 5. Obviously I'm saying without repetition. Okay, so let me just clarify it every now and then so that you don't get confused. Without repetition. So 5-letter word, that means you have to use all 5 words. You can't keep any word of Koli aside. You have to use every alphabet. So let's try to fill the leftmost one. So you can fill it in 5 ways. You can either use K or O or H or L or I. You can use any alphabet that you want. Let's assume you have used one. So you have 5 ways of filling the first one, into 4 ways of filling the second one. Let's say anyone you have used. Then you have 3 ways of doing the third one. Then you have 2 ways of doing the fourth one. And obviously you are left with only one option. You can see 5 into 4 into 3 into 2 into 1 is nothing but 5 factorial, which is nothing but 5p5 if you do the simplification. So whether you use the concept of counting it individually or whether you use the formula, we'll get the same answer. So basically 5 factorial is 120. So there are 120 different words that we can create using the letters of the word Koli. Now some people ask me, sir, what if the word that you have chosen has alphabets which are repeating? Yeah, very good. That is a doubt that I always had. Let us use my name itself. My name is Pavan, Pavan. So I am also having 5 letters in my first name. So for example, if someone asks me, in how many different words can you form using the letters of the word Pavan? 5-letter, again 5-letter. Now the question is similar to Koli. I can also say that the answer is 5 factorial, but immediately you will start questioning me, sir, don't you think you are wrong? Because you have an alphabet A which is repeating twice. Don't you think the answer needs to be relooked at or revisited? If that was the doubt that you have, that means your thought process is right. The reason being, the 2 A's are no different. Yes, it's not a capital A and small a, right? So the 2 A's are one and the same. So when you are trying to do arrangements where the objects are similar, or when you are trying to arrange, or when you are trying to create numbers where the numbers are same, or when you are trying to create words where alphabets are common, basically there seems to be a repetition. So even if I interchange these 2 A's, will it make any difference to the word Pavan? Yes, it does not make any difference. So you might ask me, sir, then why are you counting it twice? Since the 2 A's are repeating, there are 2 A's. So basically you need to divide the answer that you arrived by assuming there is no difference with the number of times that A is repeating. So basically first I will write down the answer in the numerator, assuming that everything is unique. So I'm assuming P, A, V, A and all are unique. So I've written 5 factorial just like Koli. Now I'm dividing it by 2 factorial because A's are repeating twice, right? So someone asked me, sir, what if two alphabets are repeating 2 times? Yes, that is also possible. Then if A's are repeating twice, I have divided by 2 factorial. Let us say V also is repeating twice, then you can divide it by another 2 factorial. Depending on how many times it is repeating, you can divide it by that many factorials, and the number of alphabets that repeat also change your answer. So instead of getting 120 like Koli, now I am getting only 60. You can see there is a lot of difference in the answer. So if alphabets repeat or if numbers repeat, right, you cannot treat them independently. They are one and the same, but you will make small adjustments to your formula, right? So that is how the basic concepts that we learn continue to hold good even in this case. Now there is a very interesting question that I have come across. For example, look at the word Koli itself. In how many ways can you rearrange the letters of the word Koli? I'm coming back to Koli. In how many ways can you rearrange the letters of the word Koli? So students said me, so the answer is 120. There's no difference. So I'll rephrase the question, or I will ask the question again. I'm using, in how many ways can you rearrange the letters of the word Koli? So Kohli by default will give you 5 factorial, which is 120 different words. Whether they sound good or whether they mean something, doesn't matter. At the end, I have 120 words, but I am not asking the number of words. I'm asking number of ways you can rearrange. So basically, rearrangement means the arrangement that I already gave you should not get counted. So essentially, in KOHLI, which is part of those 120 unique words, KOHLI is not counted. So basically, my answer becomes -1. So it will become 119. So there is a very small difference, but it is very, very important for you to identify, for the simple reason when we are doing a problem in the exam, we generally try to read only those things that we want to understand. We generally do not read the things which are actually needed. So the word rearrange makes a lot of difference. Imagine getting 120 and 190. You might say the answer is hardly there is a difference, but imagine the exam. It makes a lot of difference for you. 1 mark is lost, and it will also give you a negative answer if negative marks does exist. So when you read the question in permutations and combinations, I suggest please pay attention to the question, read it more than once wherever you feel it is necessary, and then proceed with the answer. So those are some of the basic models, guys, with respect to permutations and combinations, right? I hope we are clear on this. These are very basic concepts. Please keep asking any questions that you may have, right? So I'll try to address these at the end. So now let me proceed to the second concept that was part of my session today. That is the concept of probability. So a lot of people kept asking me, sir, why are we doing it together? Why should we do permutations, combinations, and probability together? So my answer is very simple, guys. Permutations and combinations and probability are basically two sides of the same coin. In the sense, when I'm trying to do probability, I'll always use the concepts of permutations and combinations. So it is always advisable that when you try to prepare on your own or when you're looking at the sessions, please try to do them together, keeping aside any statistic parts of probability that you may have. The core concepts of probability can still be learned using permutations and combinations. Okay, so let's use the concept of probability. Let me just give you the basics of probability, guys. I think this is one concept which probably does not require any explanation, because everyone by default knows what is probability. So some people say that it is luck, people who does not like maths. Some people say that chance. Some people say odds in favor. Some people say odds against. So I'm very happy that people know the different synonyms to probability. But at the end of the day, probability tells you that it's like a chance out of the total. What is the possibility of the event that you want to happen? What is the ratio? For example, if I ask you a very simple question, let us say very popular director, Mr. Rajamouli, is making a movie called Triple R. So if I ask you, what is the probability that Triple R that Mr. Rajamouli is making will be a hit, right? So people will start thinking, how can we even answer this question, right? How can you even say something related to this? Because nobody knows whether the movie will be a hit or a flop. Yes, I agree, because in probability also there are two subjects of probability. One is subjective probability, second is objective probability. So subjective probability is something that you can answer using your own judgment, right? It is subjective. Then there's something called as objective probability, which you can basically derive based on certain data points that you have. For example, if you want me to answer using subjective probability for the question that I just asked, I will say my gut feeling is, looking at the teaser and the trailer, it will be a big hit. Not a trailer, just a teaser. But if you ask me to answer this in a way of objective probability, I will say that this popular director has directed almost 10 to 11 movies till now. Correct me if my number is wrong. And all the movies so far has proved to be box office success. So I will say, what is the probability of this movie being a hit? I will say 100% using the concept of objective probability, right? So that's basically difference. So probability using P always lies between 0 and 1. So you can see that I've used the word equal to as well as less than, less than. So what does 0 represent? What is the probability 0? 0 represents probability the event will not happen. What is the probability 1 means? It is always going to happen. It's like impossible event and a sure event. Probability 0 means it will never happen. Probability 1 means it will always happen, or a sure event. Now, basic example that you know, whenever I toss a coin, a single coin, what is the probability of it being a head, right? So when we say coin, there is always a word that is used, unbiased. So you will come across these terms because everything needs to be very specific. That means I don't want a coin which has heads on both sides. It doesn't make any difference. Unbiased coin means which is a regular coin which does not have any bias either for a head or a tail. Then probability of it being a head will be 1/2. So when you use the word 50%, some of you might say 0.5, some of you might say 50%, some of you may say 1/2. I'm very happy because all three mean the same for me. So when you toss a coin once, either you will get a head or you will get a tail. Guys, remember this is called sample space. That means all the possible outcomes of a particular event. The event is tossing a coin. When I toss a coin, all the possible events that can, all the possible outcomes that are possible for this event are written in the sample space. So my sample space I will put in this flower brackets. So this flower brackets has a head and a tail. So how many outcomes are possible? 2. So the denominator always will tell you how many outcomes that are possible. Now my question is, what is the probability of it being a head? Now you can see there are 2 outcomes. So denominator will have 2, and you want the toss to be a head. That means you want only 1 out of the 2 to happen. So probability basically tells you the number of events in your favor in the numerator divided by the total number of events in the denominator. So in this case, 2 possible outcomes are there. So denominator is 2. Since you want only a head, so I put the numerator as 1. So probability of it being a head, P of H is equal to 1/2. Now in the same context, if I ask you what is the probability of it being a tail, you will say, sir, the answer is P of T is also 1/2. Yes, very good, because these events are equally likely. That means probability of head is equal to probability of tail. And when you add these two, you will get 1, because these are equally likely events because their probabilities are equal. Okay, so just to reiterate, probability 0 being it's an impossible event, probability being 1 is a sure event, like the movie that we are going to see, Triple R. It will going to be a definite hit, right? Hopefully my example stays good even after the movie gets released. So this is basically the concept of probability. Okay, so let me understand the concept of probability using one more example, the concept of dice. When you roll a dice, okay, so you know a dice has 6 phases, like this in a 3D, right? Right, 6 phases. Suppose I roll a die. Okay, I roll a single die. Now if I ask you what is the probability of the number on the top face being a prime number, if I ask you this very simple question, so first you need to tell me what is the sample space, right? When I try to write what is the sample space, you might say you can get 1, you can get 2, sir, you can get 3, you can get 4, you can get 5, you can get 6, because any number is possible, right? When you roll a die, right? When you roll a die, any number is possible. But do you want all to feature on your top face? No, you want only prime numbers. So I want either a 2 or a 3 or a 5. I don't want 1, 4, and 6 because those are not prime numbers. So as some of you are correctly writing in the answer place, right? As you are correctly commenting, the total number of events are 6 and the numbers that are in my favor are 3. So you will say the answer is 1/2, right? We also have Dilip asking in the section, sir, what is conditional probability? I'm very happy that you asked Dilip, because the next concept that I'm going to explain is conditional probability itself. So the word is very interesting, right? You have something called as probability, and it is joined with another word called conditional. Okay, so let me use a very simple example to explain you this, guys. Okay, so before I get on to conditional probability, okay, so I will say, or Indigo is saying that we are assuring that our program, right, CA foundation program will give you best result, right? But what is the condition? The condition is that you should put your best efforts and make the best use of our curriculum and put in the best effort, and definitely you'll come out with flying colors. So that's the condition. So the question is, does each one of you eventually clear the exam? Yes, provided you meet the conditions. What are the conditions? You put your best effort, you complete our syllabus, you use all our material that we share with you. If you do all that, then definitely you will clear, right? So here the word conditional probability is also called as a probability which is arrived after you meet certain conditions. Okay, so how do we represent it and what is the use of it? It's very important that we learn this. Okay, so conditional probability, right? So let us say we have two events. So let me write two events on my screen. Guys, toss a coin. Event number 2, roll a die. So very interesting, right? Don't you think it's very interesting? Yeah. So these are two events. Let's say this event is A and I make this event as B. Okay. So tossing a coin, you know, you will either get a head or a tail. This is my sample space, guys, for event A. For event B, the sample space is 1, 2, 3, 4, 5, 6. I hope we have already discussed how the sample space is arrived. Okay. Now conditional probability. Let us say I toss a coin, and if I get a head, then only I will roll the die. What if I get a tail? I will not roll the die. So the rolling a die or using the die is conditional upon you getting a head. So if you just have to roll a die without any relation to tossing a coin, then you are at free to roll the die at any time you want. But you can't roll the die now unless you get a head. Now, whatever total possibilities that you had now becomes only 50% because this event will not allow you to do the next event. You will be able to roll a die only when you complete this event, or a vice versa. Okay, so how do we use this notation? So basically, it is basically used using a notation called P of A by B. Now, what does it mean? Or P of B by A. So someone asked me, sir, what does this mean? Why are such complex things coming in probability, which is very easy? I'll say, boss, even P of A by B or P of B by A is very easy. We just have to understand the notation. Now, what does A by B mean? I can't have two things in the same brackets. If you say, yes, I also agree with you, but it's very easy to understand. No, please remember, in the brackets, I have two alphabets, A and B. What is the numerator? A. That means I am only interested in A. But what is then the denominator also reminds you that P of A by B tells you probability of event A happening provided B already happened. Remember, that means the one which is in the denominator has already happened. After that, the alphabet, the numerator is happening. So P of A by B tells you probability of event A happening provided B already happened. Similarly, P of B by A tells you probability of B happening provided A already happened. Are we clear on this? Now, someone asked me, sir, what does this represent mean? Right? P of A by B intersection C. Yeah, very interesting. Even I am very curious to know what do these things mean. So here, what does this notation mean? Probability of event A happening provided both B and C happened. right? B and C. Why is the word and? Intersection means both in your Venn diagram. So probability of A happening provided both B and C happen. It's like three events linked to one another. Don't you think it's very interesting? Yeah, yeah, yeah. So now let me just write how do you derive the formula for P of A by B or P of B by A? So please don't try to remember the formula. Let's discuss only one thing, guys. What does P of A intersection B represent? Let me ask you a very simple question. What does A intersection B happen? What does A intersection B mean? A happened and B happened. This word means and. Intersection means and. Okay, and. So A happening and B happening. Now the question someone asked me, sir, whether A will happen first or B will happen first. It's your call. So let's assume A happened followed by, that means into, followed by B. So should I stop here? No, I should write B by A. Don't you think so? Because P of B by A tells me that A already happened, after which B is happening. So P of A intersection B, if I am looking at a conditional probability, it should be written as P of A into P of B by A, or you can take B first. Nothing stops you from doing it. P of B into P of A by B. I hope this explains you in detail what does P of A intersection B mean in a conditional probability. Now, if you want to derive the formula of P of A by B, feel free to do so. It will become P of A intersection B by P of B. If you want to derive the formula of P of B by A, it will become P of A intersection B by P of A. So I think it's very simple to derive the formulas on your own rather than just remembering what is given in the book, because it will not help you in the exam, because you will try to remember too many formulas, you will not be able to recall them properly, right? So you don't have much of complexity in the problem, so it's very easy for you to derive on your own. Someone asked me, sir, with respect to Bayer's theorem, guys, Bayer's theorem is little complex in the sense that if I have to do it, probably I need a big question for you to explain. We'll discuss Bayer's theorem in detail at a later point of time. Since someone asked me what is conditional probability, yes, I have explained it. Yes, conditional probability is the foundation of Bayer's theorem. I'm not denying that, because Bayer's theorem application problems is based on conditional probability. If you don't understand conditional probability, even your Bayer's theorem is not relevant for you. Okay, so we can use these concepts even to solve the problems of Bayer's theorem. So probably you can relook at some of your questions, and then those will be much more meaningful for you when you try to do it. Okay, so let me try to explain you one example, right, with respect to probability, guys, right? So in probability, let's try to use an example from cricket. Okay, so let's try to use an example of cricket, right? So let A represents, so let A represents, so let A represents that, so let us assume that we are actually in a final of a major cricketing tournament, and we have two popular players who are trying to uh, make it big on this occasion. So let's assume they are Kohli and Rohit. So these are the two cricketers that I'm explaining you now. Okay, so let's assume we have some data, guys. So the data tells that in finals of major cricketing tournaments, let's assume both these cricketers have participated. Kohli has participated in 20 major finals, and Rohit has participated, let's say, in 25. Okay, so these are the number of matches they have played in terms of finals. Okay, so out of these 20 matches that Kohli has played, the number of times he scored a century, okay, is, let us say, 15 times. You can see that Kohli is a big match player, guys. He will do well on major occasions. The number of times he did not score a century, no. Let's assume, let's use the word P and Q, so it's easy for you, uniform. So P and Q. It's easy for you. So out of the 20 matches that Kohli has played before the final that we are discussing now, in those 20 matches, on 15 matches, he scored a century. In 5 matches, he did not score a century. Similarly, Rohit Sharma has played 25 finals representing India. In those 25, he scored a century on 20 occasions and he did not score a century on 5 occasions. You can see that both these cricketers seems to be doing really well. Now we have a final. Both Kohli and Rohit are part of this final now, guys. Okay, right? Now my question is, what is the probability that both Kohli and Rohit score a century in today's match? Let's assume we have a match today. And what is the possibility that both Kohli and Rohit score a century? Right? That means I want Kohli also to score a century and Rohit to score a century. That means it is a classic case of two events happening at the same time, right? That means I want Kohli to succeed and I want Rohit to also succeed. So let's assume KR. K means Kohli succeeding, R means Rohit succeeding. Now, what is the probability of Kohli succeeding? Do you have any data to tell you that answer? Yes, I have the data. Out of the total 20 matches that Kohli played, before this, he scored 15 times. He scored a century in 15 such occasions, which effectively translates into 3 by 4. So 3 by 4 is a very good number. Nobody has 100% probability, right? So Kohli 15 by 20 translates into 3 by 4. Now what about Rohit? Rohit played 25 matches in total and he scored 20 times. It translates into 4 by 5. 5 fours are 5 fives are. So when I do a multiplication of both, you can see this becomes 3 by 5. So what does 3 by 5 represents? 0.6 or 60%. That means what is the probability that both Kohli and Rohit score a century in today's match? I would easily say the answer is 60%. Yes or no? Because both Kohli and Rohit has to score a century. So it will be Kohli's success into Rohit's success. Now someone asked me, what is the possibility that only one of them score a century? Sir, can you please explain that? Yes, I'm very happy. Reason being that I did not specify who's scoring it. I just said only one of them should score a century. Now it's your call. If you want only Kohli to score a century, you may be Kohli fan. I want only Rohit to score a century. I may be Rohit fan, but mathematics does not distinguish between Kohli and Rohit. You have to consider both the scenarios. That means you have to consider a scenario where Kohli succeeds and Rohit fails. I use a concept of bar to tell you that he fails, or use the word or. Use the word or. Kohli fails, Rohit succeeds. Now, please you identify the symbol plus because both are independent events. So, what is the possibility that Kohli succeeds 15 out of 20, right? What is the possibility that Rohit fails? Rohit, out of the 25 matches he played, he did not score a century in only 5 matches. So 5 upon 25. Now you can't just stop at only doing it for Kohli because when Kohli scores a century, Rohit should not score a century. So I should read it as Kohli scores a century and Rohit not scoring a century. Since I use the word and, I'm doing into, or Kohli not scoring a century 5 upon 20 occasions into Rohit scoring a century, which is 20 upon 25. I hope this makes sense for you. So basically this will be 3 by 4 into 1 by 5 plus 1 by 4 into 4 by 5. So if I just don't do any other things, so this will become 3 by 20 plus 4 by 20. If I don't cancel anything because I want the denominator to be same, my answer will be 7 by 20. So don't you think this is very interesting? I just said one of them has to score a century. The probability of this happening is 7 by 20, which if I convert into percentage, it will be 35%. What is the probability of both scoring a century? We got as 60%. Only one of them scoring a century is 7 by 20. What is the possibility that none of them score a century, like what happened in the World Cup semi-finals with New Zealand? What is the answer for this? Then you can say, sir, now I am very clear. It should be Kohli is failing and Rohit is also failing. Yes, you are on the right track. What is the possibility that Rohit fails or Kohli fails? 5 upon 20. What is the possibility that Rohit fails? 5 upon 25. So basically 1 by 4 into 1 by 5. So basically this translates to 1 by 20. So what is the possibility that none of them scoring a century in the final or the big match? 1 by 20 is only 5%. Though it's a very small percentage, it did happen when we played semi-final with New Zealand. Don't you think so? So probability of even 1% can make a lot of difference. So when we are discussing about probabilities, these are certain things that you need to keep in mind, that the word and or. So again, I repeat, when I use the word and, I'm referring to multiplication. When I use the word or, I'm referring to addition. This will be very useful even when you're doing combinations, where you have to select committees, where you are having multiple cases with you, correct? Right? So these are some of the concepts that you should be aware when you are trying to learn probability, guys. Please remember, guys, in probability, you also have something called as Venn diagrams. So basically we learn probabilities using Venn diagrams also, right? And you also have in probability something related to statistics called expected value. So that we'll discuss in detail at a later point of time. Since we are only discussing about concepts which are directly linked to your permutations and combinations, I did not get into that concept in detail, but your probability, basically you can treat it as an extension of permutations and combinations, right? So your Venn diagrams also are important for your exam, right? So permutations and combinations and probability both go together. So when you learn, please try to learn them together. At least the first part of your probability, which will help you address that. Okay, so this is about probability and conditional probability. For those who are looking at Bayes' theorem, guys, it is an extension of conditional probability. You are not very concerned about that. But when you are learning probability, you will see a lot of terms. Please don't get carried away by those terms like event, sample, unbiased, right? Mutually exclusive, exhaustive, equally likely. Those are all terms that are used to make it very clear what is the problem that we are trying to deal with. So basically, probability will help you. So before we wrap up, I'll explain you one more concept which a lot of students are not very clear about. This is one of the terms that I've used at the beginning of my session also. Yeah, so Dilip is asking, sir, if scoring a century by both is 60%, the scoring century by none of them should be 40% as their complementary. No, Dilip, what you need to remember is when I'm having a sample space with Kohli and Rohit, you are trying to see that there are 4 possibilities, right? This is KR, that means both score centuries. K bar, R bar, which is none of them scoring a century. K R bar, that means Kohli scores a century, R does not score a century, that is Rohit. Or you can have K bar R, that means Kohli does not score a century, Rohit scores a century. When you try to add the probabilities of all 4, then you will get 100%. So you can't say that because this is 60% KR, that means both of them scoring a century, these two will add up to 40%. That means you are basically ignoring this K bar R bar. This sample has 4 outcomes. You can't say there are only 3 outcomes. So basically, when you try to solve the problem, you will see that Kohli and Rohit scoring a century, we got 60%. Both failing in the match, we got as 5%. That's the reason I explained all 3 scenarios. And a possibility of only one of them scoring a century as 35%. You can see that when I add all these 3, I'm getting 100%. So basically for this problem, I have 4 possible outcomes. So you can't just decide 60% is one, 40% is other, because 40% is a combination of 3 other events. So that is what you should be very careful while doing the problem. Complementary events are there, but complementary events answers will come only if you are sure how many outcomes are possible. Like in a head and a tail, what is the probability of head falling 1 by 2? What is the probability of tail falling is also 1 by 2, because there are only 2. But whereas in Kohli and Rohit scenario, we have 4 outcomes. So if you find the answer for one, the rest 3 combined will be the balance. You can't exclude anyone from the other. Okay, so this is what he asked. So Tarun is asking, sir, is there anything called mutually exhaustive? No, there is something called as mutually exclusive and collectively exhaustive. So both are different. So what is mutually exclusive events represent? You can see the word mutually and you can look at the term exclusive. Exclusive means unique, separate for you, right? And mutually. For example, you toss a coin, head, if it falls, you are sure tail will not fall, or when tail falls, head will not fall. So those are called mutually exclusive events. Both are independent of each other. But what is collectively exhaustive? Collective exhaustive means when you toss a coin, you know that when you have the probabilities of head and tail only, and when you add them, you will get one. That means all possible outcomes, if you add, you'll get 100%. Collectively exhaustive. So the word exhaustive tells that it's completed. For example, when I read a newspaper, right, I read an article saying that there was a robbery at a place, right? There was a robbery in a jewelry shop, and the police has conducted an exhaustive search. What does exhaustive search mean? Exhaustive search means they have covered the entire possibility, they have covered the entire premises so that they don't miss out on any clue. Exhaustive means 100%. So mutually exclusive means one event happening, the other event does not happen. Collectively exhaustive means all possible events are covered, and when you add their probabilities, you will get 100%. So P of H plus P of T, head plus tail, is equal to 1, which is 100%. They are collectively exhaustive. P of H happens, P of T does not happen. P of T happens, P of H does not happen. They are mutually exclusive. So there is nothing called as mutually exhaustive. Maybe when you combine both, we may use a shortcut saying that they are mutually exhaustive, but otherwise in probability, we don't have something called as mutually exhaustive. So these are some of the basics of PNC and probability. Hope you have liked this session. So please work on the problems that you have access to from our app. Please make the best use of it. And for any queries, please keep posting in the app. We'll come back to you. Thank you.